Hello everyone, this video is brought to you by the Atılım University OpenCourseWare project for the course Physics 101. The lecture notes are prepared by Associate Professor Dr. Hüseyin Oymak and the video lectures are prepared by Ümit Alkuş. In this video, we will solve one problem in Chapter 10. An object of mass small m is attached at one end of a thin rod of capital M and length small d. The so obtained system rotates rigidly around the rotation axis through the other end of the rod with an angular speed omega, which is 0.5 radians per second. Calculate the system's rotational inertia and kinetic energy, both with respect to the rotation axis. The rotational inertia of the rod about an axis perpendicular to it through its center of mass is I sub rod com, where com is the center of mass, equals 1 over 12 times capital M times d squared. In the solution part, first of all, let me write the given quantities in a SI unit system. In part A, to find the rotational inertia of the system, we make use of the parallel axis theorem for the rotational inertia of the rod, because we are only given the rotational inertia of the rod through its center of mass. Therefore, rotational inertia of the rod with respect to the rotation axis is found by this formula, where subscript n represents the rotation axis and subscript com represents the center of mass. Here h is the perpendicular distance from the center of mass of the rod to the rotation axis. If we put the given values into this equation, we obtain 1 over 12 times capital M times d squared plus m times d over 2 squared. As a result, we obtain the rotational inertia of the rod with respect to the rotation axis as 1 over 3 times capital M times d squared. Thus, the system's rotational inertia is just the sum of the rotational inertia of the rod with respect to the rotation axis and the rotation inertia of the small m with respect to the rotation axis, that is m times d squared. Now we put the value of the I rod end into this equation to get, and after rearranging this formula we obtain 1 over 3 times capital M plus small m times d squared. As the final step, we put the numerical values into this equation as follows. And if you calculate, you obtain this result. Notice that the unit of the rotational inertia is kilogram times meter squared. And the result in 3 digits is approximately 4.76 times 10 to the power minus 3 kilogram times meter squared. Okay, in this part, we have found the system's rotational inertia. Now, let's find the kinetic energy of the system with respect to the rotation axis. To find the rotational kinetic energy of the system, we use this formula, which is 1 over 2 times I system times omega squared, where I system is the rotational inertia of the system with respect to the rotation axis, and omega is the angular speed of the system with respect to the rotation axis. Now we put the numerical values into this equation and we obtain the kinetic energy of the system with respect to the rotation axis as 5.95 times 10 to the power minus 4 joules. Alright, this is the end of the discussion of this problem. Thank you for your attention and see you in the next video.